In this video, we're going to be learning how do we find the average value of a function. So if a function is able to be integrated on the interval a to b, then the average value of f on the interval is, and we could represent this by 1 over b minus a times the integral from a to b of f of x dx. Or we could rewrite this and take the integral from a to b f of x dx and divide that by b minus a. What this is basically doing is finding an average. We know that integrals can help us find sums. And let's say we're finding the average of some test grades, let's say 3 test grades. We would add up the tests, divide by 3. So what we were doing here, and you could see the division a little bit more in this example, but basically we're dividing by how many values we have, and that will give us our average value. In this video, I will be using the 1 over b minus a version times the integral, but you could use either version to get an equivalent answer. All right, for number 1 through 4, we're going to find the average value of each function on the given interval. All right, for number 1, we have f of x equals 3x on the closed interval 1 to 5. So setting this up, we would have 1 over 5 minus 1 times the integral from 1 to 5 of 3x dx. This is, of course, going to give us 1/4 here. And we're going to find the antiderivative of 3x. So that's going to give us 3x squared over 2. And we're going to evaluate that from 1 to 5. When we evaluate, we're going to be using the fundamental theorem of calculus, basically plugging in the upper bound, plugging in the lower bound, and subtracting those. When I do this and I simplify, distribute that 1/4 in front, I'm going to get 9 as the average value. Just as a note, if you have your calculator and you are able to do this, you could also go from this line and plug that into Math 9 in our calculator in order to get our answer. All right, let's take a look at number 2. Similar problem, but new function and new closed interval. So we're looking for the average value of x squared from the interval 0 to 3. So this is going to be 1 over 3 minus 0 times the integral from 0 to 3, x squared dx. When we simplify this, we're going to, of course, get 1/3 over here, and here we are going to find the antiderivative of x squared. So that's going to be x cubed over 3, which we'll be evaluating from 0 to 3. So let's use the fundamental theorem of calculus again to basically plug in our bounds and subtract. And when we do this, we are going to get 3 as our average value. All right, let's try another one. So now we're looking for the average value of cosine x from the interval 0 to pi. So we're going to do 1 over b minus a, so 1 over pi, times the integral from 0 to pi cosine x dx. The antiderivative of cosine is sine. And we'll be evaluating that from 0 to pi. When we do that, we're going to get 1 over pi times sine of pi minus sine of 0. And in order to simplify this, we would have to know what sine of pi and sine of 0 are. So if we had our calculator, we could, of course, plug that in. But I like to think about my unit circle. So sine of pi is basically the y value over here. So that y value is 0. Sine of 0 is the y value over here on my unit circle. That is also 0. And therefore, our average value is 0. Okay, let's try another one like this. So for number 4, we're looking for the average value of 2 radical x from 4 to 9. So we could rewrite this, by the way, as 2x to the 1/2 power. We'll be using that when we integrate. All right, so for the 1 over b minus a, we're going to have 1 over 9 minus 4, so 1 over 5, times the integral from 4 to 9, 2x to the 1/2 power dx. Okay, let's find our antiderivative. So basically using the reverse of power rule, I'm going to add 1 to that exponent and divide by that number. We could also think about that as multiplying by the reciprocal. That would be the same idea. And we will be evaluating this from 4 to 9. So I'm just going to clean this up a little bit before I evaluate. So I'm going to put this as 1/5 times 4 square root of x cubed over 3. And that's what we will be evaluating from 4 to 9. So to clean that up, what I did was I multiplied by the reciprocal, so multiplied by 2/3. And I also took that rational exponent and put it back in a radical format. So x to the 3/2 is the same thing as the square root of x cubed. All right, we will now plug in our bounds. And we're going to evaluate this. So if we do this by hand and we sat here and actually cubed 9 and took the square root of that and so on, we did all of that arithmetic, we are going to get 76 over 15. If we're looking for a calculator equivalent though, and let's say we're going to round to the nearest 3 decimal places, so nearest thousandth, I could have 5.066 or 5.067. So on the AP exam, our general rule of thumb is we want at least 3 decimal places. So 5.066 or 5.067 would both be correct in this case, right? If there were specific rounding directions to round otherwise, let's say the nearest tenth, then of course you would have to follow those. All right, let's try an average value problem that's a little bit different because it's more of an application question. We're looking for like a real life scenario. So it says, suppose you are monitoring the temperature in a room over the course of a day. The temperature of the room in degrees Celsius, R of T, changes throughout the day and is modeled by the following function. Okay, so R of T equals 20 plus 0.5 T. We're going to find the average temperature of a room over a 6-hour period from T equals 0 to T equals 6, and we're going to include units in there. For this question, it's important to note that once we see this word average, that would be our indicator that we're looking for average value. It's just that that value in this problem has an actual context to it, and it's really representing average temperature. So what I'll be doing is I'll be doing 1 over b minus a, which is going to give me 1 over 6, times the integral from 0 to 6, 20 plus 0.5 t dt. Okay. If we are integrating, we can now find the antiderivative. So 20t plus 0.5 t squared over 2. And we'll evaluate from 0 to 6. And then I'm going to plug in my bounds. Okay, again, if you have access to your calculator during this question, you could just do math 9 once you have the integral set up. And when I simplify this, I'm going to get 21.5. Now, this question is asking for us to include units. So let's just think about what it's asking us to find. It says find the average temperature of a room. So our unit should be talking about temperature. And in this case, the unit for temperature in this problem is degrees Celsius. Okay, let's try one more real-life application problem. So it says, suppose you drive on a road trip for 5 hours and your velocity can be represented by v of t equals 50 plus 20 sine pi times t over 5, where v of t is in miles per hour and t is in hours. Find your average velocity from t equals 0 to t equals 5 hours, including units. So very similar question to number 5. So we're going to put our 1 over b minus a in front, so that's 1 over 5. The integral from 0 to 5, and then we're going to use our function v of t here. All right, for this one, I'm going to use the calculator to evaluate this. So I'm going to be plugging this into Math 9 in order to evaluate. And when I do that, I get 62.732. And we're looking for units here. So remember, it's asking us for average velocity. So our units have to be something for velocity. If I read in the problem here, I can see that the velocity unit is miles per hour. And that would be our completed answer for number 6.